as I can see, only I think 4 people has joined. So shall we wait some more time? Am I audible to you?
Yes, ma'am. You're audible.
So not many people have joined. So we shall we wait for some more time or shall we start? Maybe we'll
Start, ma'am, because
yeah, yes.
you should start, ma'am, because people know what is the exact time of starting the meeting, but they don't come. So in the next 5-10 minutes, they will not come.
So maybe we'll wait for now it is 4:42. We'll wait for 4:45 and we'll start. Okay.
Okay, ma'am.
So we'll start our session today. First of all, I think I guess you people has been shared the last assignment, analog assignment that is based on voltage regulator using Zenitide, right? Am I audible to you? Please confirm that whether you guys have been shared the assignment of voltage regulator using Zenitide. It was informed to you that it will be shared in the last week. So I wanted to know whether everyone has at least tried out the experiment. Am I audible to you guys?
Yes, ma'am. You are audible,
So
ma'am. But your voice
yes.
is not too clear. Little bit. Try. voice
Hello?
is not
Yeah,
too clear. So,
it's not clear.
it's clear, but not too clear. But right now it's clear.
Okay, okay. So I'm asking that whether if you people have bought the assignment for voltage regulator using Zener diode, whether you people have tried the experiment or not.
Yes, ma'am, I tried, but I faced some difficulty in a new software. New software. So can you please explain a
LD
little bit?
Spice. Okay.
Yeah, yeah.
So what difficulty did you
How to use
face?
and how to connect and everything.
Okay, okay, okay. So there are tutorials in the YouTube. Have you gone through that? And I think in your website, in your tutorial assignment document, it is already a link has been shared to you. So you have in that link, if you go, there are resources library, reference designs for you to just start. Okay, just go through those tutorials. It will be helpful for you. Okay.
Yeah, ma'am, I tried. A little bit I understand, but if you once you can explain, then it's better for.
Okay, okay. I can give you a just basic.
Yeah, yeah,
Yeah, I can give that. Because Zener diode, and one problem with the Zener diode that has been specified in your document, assignment document, is that uh, select a Zener diode with a 3.6 volt Zener breakdown voltage. Okay, so I don't think you will get a Zener diode having 3.6 breakdown voltage. So that you have to figure out. I think that I have also not tried, but I can give you a basic outlook on how to add components and how to connect the components and how what components you have to use. Those things I can give you a basic idea of. So just,
yeah, ma'am.
just a minute. I'll share my screen. So first of all, I'll give a brief of what the experiment is all about. So it is about the development and testing of a voltage regulator using Zener diode. So sometimes we'll have a voltage fluctuations in a DC voltage. Uh, so for that, we need to have a voltage regulator that has been done using a Zener diode. Zener diode is actually this is done by using the reverse region of the Zener diode. That is, in the Zener diode, there will be a breakdown region. In that, if you increase the voltage more and more, then also the current flowing through that Zener diode will be constant, and the voltage also the VZ after that. Uh, if you increase the source voltage, also the voltage across the Zener diode will remain constant. So this is the experiment is all about. Now, first of all, we are you people has been asked to mm, do a simulation study using LT Spice, so that you'll understand the basic working of the Zener diode and have a like idea that how the voltage variation will happen and how that the variation in different components of the circuit will also help in regulation of the voltage. So that is one, the aim of this assignment. So first of all, you have to refer the figure one. If you can, are you able to see my screen?
Yes, ma'am.
Yeah. So refer figure one. So RS you have to keep 250 ohms, and the voltage source, that is VS, it should be 4.3 volt DC plus another voltage source that you have to add, that that will give the ripple, should be 0.5 volt. The peak voltage should be 0.5 volt. Now it can be done as like any like DC voltage you can use. You can use 5 also, 5 volt also, as per your requirement. Now series resistance is asked to be kept at 250 ohms, and then you have to select a Zener diode with a 3.6 Zener breakdown voltage. Now RL, there is a load resistance RL. So if for voltage regulation, there can be, you can, there is a limit that how much RL, maximum RL can be reached, or how the minimum resistance value you can go. Then also you will have a voltage regulation. So this is the aim of this experiment, that if you increase the value or decrease the value of RL, so to understand what is the limit, till that limit you will have a voltage regulation. Other than you, if you cross that resistance value, if you go below that resistance value, your voltage regulation will not happen. If you increase in more, go beyond that resistance value, your voltage regulation will not happen. So there are some that limits in the load resistance value, that is to be maintained to have a voltage regulation. Same goes for series resistance and VS resistance. But in this experiment, we are only concentrating on RL, that is the load resistance, the variation of RL. So in the point number 6, vary the load resistance from 10 kilo ohms to 100 ohms and record the range of RL for which the regulator provides a regulated output voltage of 3.6 plus or minus 0.2 volt. That means the output voltage that will come in the out across RL should be 3.6, and there should be variation, maximum variation, like maximum variation should be 0.2 plus or minus 0.2. More than that, there is no, we can say that there is no voltage regulation happening. Now you have to take the input output voltage waveform, screenshots of those waveforms, and share with us in the video. Now 6 and 7. Repeat step 6 and 7 after connecting two identical Zener diodes in series. That means what? Here only one Zener diode is given. You have to attach one more Zener diode in this and see how the voltage regulation is happening, where the voltage regulation is actually happening. So that you have to give explain in your video and give a valid reason that whether or not the voltage regulation is happening or not. If not, why? If yes, then why? Then that explanation you have to give in your video. Then repeat the steps 6, 7, and 8. For now, the series resistance you will change to 500 ohm and check how the voltage regulation is happening. What is the RL limitation? Because how low the RL can go as compared to when the the series resistance was 250 ohms. So that also you have to report in your video. From the circuit with one Zener diode, RS vary and determine the range of VS2 for which the output. Now, in the 10th point is from the circuit with one Zener diode. Now, RS 500 ohm and RL 1 kilo ohm. So here, the last point is RS should be 500 ohm and RL 1 kilo ohm. Now you have to vary is VS2, that is this one, 0.5 volt. VS2, and determine the range of VS2 for which the output voltage is within the specified limits of 3.6 plus or minus 0.2 volt. This is the first experiment that you will be doing with first part of the experiment, that is a simulation study. Now the same thing you have to replicate now experimentally. You have been provided a Zener diode, obviously. Set up the voltage regulator circuit on the breadboard according to the schematic in figure 1. Now generate Vs through your pixel pulse software, an ADLM kit. This will be a triangular source with a DC of 4.3 and the maximum and minimum limits you can give. So if you want 0.5 peak-to-peak voltage of the VS2, then what you can do is generate a voltage, triangular voltage whose maximum is 4.8 and the minimum is 3.8. That's it. Now again you have to vary RL within the available range and record relevant waveforms. If the available potentiometer range differs from specified values, test RL within the available list. So you are given already a potentiometer. So change that potentiometer value, and if potentiometer range is not satisfactory, you can use the individual resistance values also and record the data and infer the what are the outcomes that you got and explanation with proper explanation in the video. That is what you have to do in this experiment. It's a simple experiment, but that is what. Now I will share with you. Now I will. I think everybody has understood.
Ma'am, I have one problem in this
Yeah.
first part. Ma'am,
Hmm.
in the second, first part of experiment and the
Hmm.
point number third, how to generate a triangular wave
Okay.
with,
Okay. That I'll
yeah,
show you. I'll show you.
okay, ma'am.
And then other than that, you have any problem? I'll give you a brief. Then also after I give you a brief, maybe you also yourself check in Google and everything. You go through the tutorials of LP Spice, just basic tutorial how to generate triangular curls. Everything it is available in the internet, so you can have that.
Okay,
Go through that just to confirm. If at all I just do some silly mistakes or something, but I will just give you a brief of the software as well.
okay, ma'am.
Okay. Other than that, do you have any basic, any confusion, any doubts for this experiment? So I'll go. I'll just share the LD Spice simulation, not video actually. I'll give you just a basic understanding. First of all, you will take a new schematic file, new schematic. Then yeah. So first of all, you will add the components. So that is the first thing you have to do. And how to add the components? There will be this symbol. Okay. So to add the components. From here you can add all the components. Okay. So first of all, we'll need a voltage source. So this is 3. Okay. Are you guys following?
Yes, sir. Yes, sir.
Yes. Okay. Fine. So I'm just going through how the schematic has been given in figure 1. Okay, just follow that figure 1. Now, what we'll need is one resistance. So LT Spice have some like shortcuts. If you press just shortcuts for the basic components. If you press R, it will directly generate. If you press R in your keyboard, it will directly generate. Otherwise, you can go here and also register as it is saying, it will come. So that is one thing. So before just clicking it, before left clicking it, sorry, yeah, left clicking it, you can do is Control R and it will rotate. Control R is a command that you have to give so that it will rotate. So this will serve as our series resistance. Again, I will press Control R. That will give our. So you have to just left click and it will the components will sit there. So that is one of the just easiest way. So we'll need then right click the This components will go. Now, what you have to do? So if you press Control and scroll, that it will zoom in and zoom out. That is as simple as that. Everyone knows. Now, what you have to do? You have to include one ground. That is our ground. Then again, right click, so it will go. Then you have to add another. This is the component. So where there you can go and get the components. Here you will it will come like this. If you slide in the right hand side, there will be Zener. Okay, so Zener type, Control R, rotate like that. Your components are done. Now, what you'll do, you will connect all those components. So you will take this wire, click on wire, and it will come. And it is very easy. You can just go through like this. Your circuit is complete. Now you will give values. So here, if you go to all the components, there will be some hand mark that will come pop up. You will right click on that, and you will give the values. Let's say RS is in the first time it is 250 ohm. Now here we'll just start with 1K, because the variation it is told as 10K to 100 ohms. So you will just come from 10K, 8K, 5K, like that. You can just check for which set of voltages it is giving it is showing voltage regulation. Now you will give the voltage source. Again, right click. Now we need a DC voltage plus there should be uh, so that we can do, going to advance. Now we'll go to pulse generation. Now as you know that our on yeah, so our uh, DC is 4.3 volt plus 0.5 peak voltage of the VS2, right? So we can directly give here. So 4.3 minus 0.5, it will give 3.8, and it is 4.8. 4.3 plus 0.5. So we can directly generate in like in place of using two voltage source separately, we can directly use that. So time delay is 0. T rise is the, for example, we are using 1 kilohertz frequency signal, that AC signal. Now the time period is 1 millisecond. Now 1 millisecond time, T rise and T fall is 1 millisecond divided by 2. So it will be 0.5 milli, and it is 0.5 milli. I'm just giving you an example. You guys can decide what you have to do. Now T on should be 0, and T period is 1 millisecond. That's it. Now you can drag and move this here. The basic. Okay. Now you have to, everything is done. Okay, fine. Zener diode we have not specified. So here you can, it is not specified anything. So we have to pick a new diode. Now we have to find a Zener diode this is the breakdown voltage. Find a Zener diode whose Zener breakdown voltage is as near as possible. For example, it is given 3.6. So there are some YouTube videos and many other videos. You can just refer them whether how to like manually change the breakdown voltage once you select a Zener diode. I'm just showing you how to get from this LD Spice software. So here, as you can see, I think 4.7. This is the minimum. I I guess I have not seen less. If you guys can spot any Zener diode with, see, the type of the diode is mentioned here. Schottky diode, silicon diode, everything. So type of the diode is mentioned with their breakdown voltage. Now, if you can just locate any Zener diode having lesser breakdown voltage, you can also opt for that. I'm just giving you an example. Let's say I'm using this one for now. So it will come here. So if you press, its properties will be given. Like breakdown voltage is 4.37 volt. Now the problem is, if we are giving 4.7 volt altogether, 4.7 volt breakdown voltage here for the Zener diode, it will not show, and we are giving 4.3 DC. It will not show that voltage regulation. That will be a problem. Why? Because the VTH across the Thevenin voltage across this diode will be very less as compared to the breakdown voltage. Not very less as compared to the breakdown voltage. So the diode will not reach the breakdown region itself. So the voltage regulation will not happen. That is a problem. So now, if you can actually get a manually change the breakdown voltage, there are videos. You can just talk within yourself and maybe figure out that, because that thing I have not figured out. I have to check also. So that thing you can do. And or else you can just increase the DC value here. Here we have done 4.3. You can just check for 4 point maybe maybe 5.3 or something like that. Increase the VS, so that will solve your issue. But at least you will be able to see the voltage regulation. If you're doing that, please inform us in the video that this is the case, and try to do that, figure out a way so that the Zener breakdown voltage comes at 3 point, I think 3.6 as mentioned, 3.6 volt, so that you will be able to see a voltage regulation, and the output voltage coming across this load resistor will be 3.6 plus or minus 0.2 volt. So that is the aim. Now you have to run. So we'll do a transient analysis, and as you have we have taken 1 millisecond one cycle, the time period of the cycle, one cycle. So we'll take 10 milliseconds. That will give us 10 cycles of the signal. Okay. So now I think previously I have done it. Okay, fine. Same thing I have done it before. Now you have to check the voltage. Okay. See, 4.8 to 3.8. The variation is coming. Okay. Now, if you want to remove this, right click, on this, delete this trace, and if you want to check how much current is flowing. You just click on the component, that thing, come and it will show how much current is flowing. So all those things. If you want to check the voltage, just do that. Voltage and current it is showing. So here it was showing IS, and here it is VS. So if you want to remove a trace, let's say you want to only check VS, then right click on the IR1 and delete this trace. It will only give 4.8 to 3.8. That is the basic.
Yeah, ma'am, this is very helpful.
Just so any more doubts you have regarding this experiment? Or any doubts regarding the previous experiment?
Yeah, ma'am, I have a small doubt.
Yeah.
You have previous experiment. In the previous experiment, ma'am,
Okay.
please, I'm opening a previous experiment PDF. One second.
Sure.
In the first part of the experiment, point number 3, measure record base current at the fixed of VV using multimeter. What does it mean, ma'am? I
Which one
didn't understand.
measure and record the base current for the fixed VBE or VGS using a. So you there is see for every BJT, every BJT that will be there will be a base a threshold voltage. Okay, VBE.
Yeah, ma'am.
Okay, so in that threshold for that fixed according to that threshold voltage you will fix that VBE in that. Okay.
Ma'am, 1 minute.
Yeah.
In my case, uh, I supply a current through potentiometer wire
Yeah. Yeah.
through base. So should I fix the output voltage of potentiometer is around 0.66 or zero point 0.7, or should I increase the voltage and what, how to do this?
Okay. I'll just tell you. So you increase the potentiometer value. So 2.5 is constant. Okay, what you can only do is change the potentiometer value, right? Potentiometer value, right? Vary the potentiometer, right?
Okay.
So you will check, you will measure constantly for VBE. So the threshold voltage given in the data sheet, you will vary the potentiometer up till that. So when the VB reaches the threshold voltage, you will keep the potentiometer value at that. Potentiometer at that. Okay.
Okay.
In that way, that will be done. Okay. Measure and record the base current. Now, once the VB is fixed, you will check how much IB is flowing through RB. Okay.
Okay.
Measure across
Ma-
RB. Measure across voltage across RB, and the voltage whatever you get that will be divided by RB will give you the IB base current.
yeah, ma'am.
Okay.
I calculate this.
Okay. You understood, right?
Yeah.
Okay. Anything else? Anyone has any doubt regarding the previous experiment or today's experiment? Maybe we'll wait for 5 more minutes and then we'll just wrap up if nobody has any doubt.
Okay, ma'am. Thank you.
Please let me know if you have any doubts for today's experiment, the voltage regulator experiment, and also the transistor experiment. Please let me know if you have any doubt. I'll wait for the next 5 more minutes. You can just let me know. If nobody has any doubt, you can leave the screen, leave the meeting. If you don't have any doubt, you can wrap up. Please leave the meeting if you don't have any doubt.
Thank you.
Please leave the meeting. Wrap up now. If I'm audible, please leave the meeting. We'll wrap up.